Now see the next topic. Next topic is electric field. Listen to me carefully. Now electric field are of two types. You know, you have studied electric field in the chapter electromagnetic induction. Correct? You have studied electric field, unit is volt per meter. It is denoted by E vector. Remember? In electromagnetic field, E is equal to C into B. Electromagnetic waves consist of two fields, electric field, magnetic field, where electric field is denoted by E vector, unit is volt per meter. Remember all that? The same electric field is here. And there are two types of electric field. One is uniform electric field and one is non-uniform electric field. Now, uniform electric field and non-uniform electric field, the difference is what, you know the difference between equal vectors. What is difference between equal vectors and unequal vectors? What do you mean by equal vectors? Can anyone tell me? You have studied
Two
vectors, right?
having same magnitude and same direction.
Same magnitude and same direction is equal vectors. Different magnitude and different direction is unequal vectors. Now, if you look at this screen, tell me which one do you think is equal, which one do you think is unequal? This one or this one?
First one is equal.
First one, can I say, is equal vectors because all have the same magnitude and all have the same direction. So if the electric field has the same magnitude and the same direction, then it is called uniform electric field. But if the vector has different magnitude and different direction or both, then it is called non-uniform electric field. Did you understand? So what is uniform electric field? Electric field having same magnitude and same direction, like same vectors. Then what is non-uniform electric field? Vectors having different magnitude and different directions. Therefore, if you notice this, uniform electric field, a uniform electric field is a field whose magnitude and direction is same at all points. Easy, because it is same as equal vectors. For example, field between two parallel plates. Now see, they have given two parallel plates over here. Just check. One is positive plate, one is negative plate. The field that is formed between the positive plate and the negative plate, that is called as uniform electric field. Continue. What is non-uniform electric field? A field whose magnitude and direction is not the same at all points. For example, field due to a point charge. That means if I take a point charge, all the fields go outward. Can I say these lines, or this is an example of non-uniform because the direction is different. Therefore, this is non-uniform electric field. Therefore, whenever you see vectors which are same in magnitude and direction, they are uniform. And whenever you see vectors which are different direction and magnitude, this is non-uniform. Therefore, if I ask you how many types of electric field are there, what will you answer? There are two types of electric field. Which are the two types of electric field? Uniform electric field and non-uniform electric field. What is uniform electric field? Same magnitude and direction. What is non-uniform electric field? Different magnitude and different direction. Therefore, in your notebook, write on the side heading electric field. Write down. In your notebook, write down the side heading electric field. In your notebook, write down the side heading electric field. Electric field, write down. There are two types of electric field. First one is uniform electric field. Second one, non-uniform electric field. Write down. There are two types of electric field. First one is uniform electric field. Second one is non-uniform electric field. First one is uniform electric field. Second one is non-uniform electric field. And you have written uniform electric field and non-uniform electric field. Now, listen. Below that, write down only what is uniform electric field. Means write down only this much first. What I have underlined for uniform electric field. Remember, I'll be asking you Viva. So the first question I'll be asking in YY is what is uniform electric field? You will tell me a field which has same magnitude and direction. What is non-uniform electric field? A field which has different magnitude and direction. Easy. Therefore, write down uniform electric field. Once you finish writing, put a dot, because below this you have to draw the diagram. Written, what is uniform electric field? Now below that, you have to draw the diagram of uniform electric field. Below the definition of electric field, below the definition of uniform electric field, you have to draw the diagram of uniform electric field. Draw the diagram. Below that, write down non-uniform electric field. Below that, write down non-uniform electric field. And write down whatever I have underlined. Once you finish writing non-uniform electric field, please put a dot, because after that you will have to draw the diagram. Okay, finished. And this is the diagram for non-uniform electric.
So please show the previous screen. No, 1 minute.
Yeah, 1 minute. Here it is.
Okay, sir. Thank you.
Finished? So listen to me. Listen to me. Electric field. How many types of electric fields are there? 2 types. Which are the 2 types of electric field? Uniform electric field and non-uniform electric field. Uniform electric field and non-uniform electric field. What is uniform electric field? Electric field which has same magnitude and direction. Example, parallel plate, because it is uniform. What is non-uniform electric field? The electric field which is not uniform. That means it has different magnitude and direction. For example, a point charge. So this is the first question. Now, based on this, there is an MCQ also in your textbook. Now, try to answer the MCQ. Yeah, this is the MCQ, which is MCQ 7 in your textbook, book back. So read the question and let me know, Shreya, what do you think will be the answer? Okay, Shreya is very busy, so it's okay. We'll ask someone else. Which of the following produces uniform electric field? Answer is 2 parallel plates. We have given the example, we have just written the notes. Now, let me change the question a little bit. Now, you'll also have to change the option a little bit. Now, the question is, which of the following produces non-uniform?
Point
Then what
charge.
would be the option? Then can I say answer would be A? Actual answer is C. But if I change the question, answer will be A. Correct, Shreya? Correct, very good. Okay. Okay, so we'll start with a little bit of Viva. We'll start with Shreyash.
Yes, sir.
Shreyash, tell me, how many types of electric fields are there?
There are 2 types. Uniform electric field
Hmm.
and non-uniform electric field.
Okay, Akshat.
Yes, sir.
Akshat, can you define what is uniform electric field?
A field having same magnitude and direction.
Rohit,
Yes, sir.
what is non-uniform electric field?
A non-uniform electric field is a field where the magnitude and direction is not same at all the points.
Now, the next topic is electric lines of force. Listen to me carefully. Electric lines of force is my next topic. In magnetism chapter, we have done magnetic lines of force. Remember, in that magnetic lines of force originate from the North Pole, the end on the South Pole, outside the magnet. Inside the magnet, they go from South Pole to North Pole. They form closed loops. They do not intersect, all that, all that, all that. Similarly, in electrostatics, I have electric lines of force. How magnet has magnetic lines of force, a charge has electric lines of force. Understood? How a magnet has magnetic lines of force, a charge will have electric lines of force. Correct, Darshan? Okay. Don't be scared, Darshan. It's very easy. Electric lines of force is very easy. Okay. And after I finish the topic, Darshan will give a summary of electric lines of force. Okay, Darshan? Yes, very good. Okay. Rohit too. Both are Rohit. So I'll have to give different names to Rohit. Yes. One Rohit, change your name. Which Rohit will change the name? Achha. One is yellow t-shirt, one is blue t-shirt. Okay. So yellow t-shirt Rohit. Yellow t-shirt Rohit.
Yes, sir.
Yes. What is your new name? Tell me. I'm getting suggestion in the chat box. Okay. We'll keep your name Mohit. Any Mohit is there in the class? No. Rohit, what is your pet name?
Sid.
Sid.
Yes, sir.
Sid. Okay, very good. Is the right time to say wake up Sid, right? Very good. Nice. Now, so Sid and Rohit. So when I say Sid, Rohit, you have to answer. Hitman, yes. Hitman is Rohit man. Okay. Now, but Darshan is very scared because he has to answer now electric lines. Okay, Darshan, we will start. This topic is dedicated to Darshan. Okay, Darshan, just for you. I am doing the topic. Now listen. The topic is electric lines of force, and listen to me. The topic is electric lines of force. Before that, let me show you the diagram of electric lines of force. 1 minute. Okay, listen, I have drawn electric lines of force. Okay, I have drawn one system. Now, looking at the system, what can you observe for electric lines of force? Because Darshan has to explain this topic, correct? Darshan has to explain this topic. You guys have to explain it to him. Now, tell me, what do you notice about electric lines of force? Something that you notice. Anyone can answer. What do you notice of electric lines of force? I can say
It
they
is
start
moving
from
from
the
positive charge to negative charge.
correct. They take off from the positive charge, means they start from positive and they land on the negative, correct? Means they take off from the positive charge and they land on the negative charge, correct? Understood the first point. Second point, listen, they do not intersect each other. Check. I have drawn 4 electric lines of force. They do not intersect each other. Now tell me, when do 2 lines or many lines not intersect each other? According to maths, when do lines
When
not
they are
intersect?
parallel.
Parallel.
Perfect. When they are parallel. Therefore, can I say electric lines of force are parallel to each other? Electric lines of force do not intersect. Electric lines of force start from the positive charge. Electric lines of force land on the negative charge. Also, they do not enter the conductor, means they do not enter the conductor, means they do not go inside the conductor. They are only on the surface of the conductor. This is the main difference between magnetic line of force and electric line of force. What is magnetic line of force? They go from North Pole to South Pole outside the magnet, and inside the magnet they go from South Pole to North Pole. But electric line of force does not go inside. Electric line of force only remains on the surface. They do not enter. Tell me, I'll tell you why, okay? Just think, if they enter, don't you think they will intersect? If they enter, can I say if electric lines of force enter inside a conductor, they'll intersect? And if they intersect, can I say they'll violate the law? What is the law? They are parallel to each other. They don't intersect. That is why they are not allowed to enter. Because if they enter inside, all of them will ultimately meet. Okay. So tell me some observations that you made. Electric lines of force originate from the positive charge. Originate means take off. Electric lines of force land on the negative charge, means terminate. They are parallel to each other. They do not intersect each other. They do not enter inside a conductor. And the last point, this is for Darshan, special bonus point. Darshan, this is Dream 11 special discount code for. Okay. The last point is electric lines of force, they take off and land normally. Normally in maths means perpendicularly. Normal means perpendicular. You know how Just think about it. Okay, think about it in your brain. How aeroplane takes off and how helicopter takes off. Can I say aeroplane takes off parallel to the ground? And helicopter takes off perpendicular to the ground, means helicopter directly takes off at 90 degree from the ground. So can I say this is like a helicopter? They take off also at 90 degree. And can I say helicopter lands also at 90 degree to the ground? Have you seen helicopter landing? Helicopter always lands perpendicular to the ground. Aeroplane always takes off and lands parallel to the ground. Have you seen? Aeroplane before landing, it is parallel to the ground and then they land, correct? Helicopter directly takes off vertically and directly lands. It takes off and lands. Understood? Therefore, these are the points of electric lines of force. Now, this diagram is only for your reference. If you want, you can draw this diagram. This is just a rough diagram. Meaning, don't draw this in the exam. This is just for your understanding. Okay? Therefore, write on the side heading, electric lines of force. Write on the side heading, electric lines of force. Write on the side heading, electric lines of force. And below that, draw this diagram as your reference. Draw this diagram as your reference. Now, written the side heading electric lines of force and then draw the diagram. Now, look at the screen. Look at the screen. Look at the screen, everyone. Now, look at the first point. Look at the first point. The lines of force originate from a positively charged object and end on a negatively charged object. Tell me, did you understand point number one? Looking at the diagram itself, did you understand that they originate from a positively charged object and they terminate on a negatively charged object? Therefore, write down this as your point number one. Start. And once you finish writing this point, don't go ahead. Just put one note in the message box. I will dictate the second point. Okay, start. Second point, listen to this. The lines of force neither intersect nor meet each other. That's it. Did you understand? Actually, not intersect means does not meet each other only, correct? What do you mean by lines are not intersecting? Means they are not meeting each other, correct? Therefore, write down. Second point, the lines of force neither intersect nor meet each other. Done?
Yes, sir.
Now, point number three. Point number three. Tell me, did you understand this? The lines of force of an uniform electric field are parallel to each other and equally spaced. Did you understand that also we have discussed? So write this point as your point number three. Actually, point number three is continuation of point number two itself, because if they do not intersect nor meet each other, they have to be parallel to each other, correct? Okay, so make a note. Now, look at point number four. Means they do not enter a conductor. That also point we have discussed. That means electric lines of force do not pass through a conductor. Means do not enter a conductor. So write this as your point number four. Write down. Okay. Written. And the last point, the lines of force leave or terminate on a conductor normally. Means the lines of force take off and land perpendicularly. The lines of force take off and land perpendicularly, or this you can write as your point 5. The lines of force leave or terminate on a conductor normally. The lines of force leave or terminate on a conductor normally. Okay, now listen to me. If I ask you what are the characteristics of electric line of force, what you need to do is you need to again look at the screen and we can go one by one. So the first thing that should come to your mind is, let me draw the diagram first. So your diagram should be plus, minus, and I'll just draw a rough diagram for you like this, correct? And in that, like this. Now, first point is they start from positive, end on negative. Second point is they do not intersect. Third point is because they do not intersect, it means they are parallel. Fourth point, they do not enter inside a conductor. Fifth point is they take off and land normally. Understood? Can I say all 5 points are represented perfectly in this diagram? Means from the diagram you can come to know all 5 points. Check: equally spaced, parallel, does not intersect. They take off from positive, they land on negative, they do not enter inside a conductor, and they are normal. That is, takeoff and landing is normal, means perpendicular. Understood? Therefore, with that, we have completed 2 important topics for today. We have considered 2 important topics for today. One is electric field, okay? One is electric field lines, and one more is uniform electric field and non-uniform electric field. So we have done 2 topics. I'll give you 2 minutes to revise. You will have to give me answer for 2 topics. What is the first topic? Uniform electric field and non-uniform electric field. And the second topic is you have to give me 5 properties of electric lines of force. But we know who is going to give us the answer for electric lines of force. We have already decided who is going to give us.
Sir,
Right? Yes.
sir, can you explain the other 2 properties, last 2 properties? Sir, I was out due to network issue.
Oh my God. Don't worry. We have our man, Darshan, who is going to explain. And that time I'll explain. Who was the person who is asking the question?
Sir, Aditya.
Aditya. Aditya, elli hogidiri?
Sir, network issue.
Network issue.
Now got connected to Wi-Fi. Another
Neighbor's
hotspot.
Wi-Fi or your Wi-Fi?
Sir, no, sir. हाँ, sir, neighbor's Wi-Fi.
Okay. No problem, Aditya. I will explain. I will explain. In the meantime, how much you have studied, you do it. Then Darshan will tell the answer.
Okay.
And after that, I'll also explain. We have Sid, we have Rohit, we have Nevan. Nevan has not answered, but Nevan has kept a very good background. I feel very happy looking at Nevan's background. Yeah. Nevan, are you in Igatpuri? Are you in Khandala? Lonavla? Satara?
No. No. I am here.
Who else has kept the background? No one has kept the background. Rutvik has kept a good wallpaper. I like Rutvik's wallpaper. That is good. Shreya is now free. Otherwise, Shreya was very busy throughout the day, coordinating many things inside her house. Now Shreya is free. Very good, Shreya. People who keep your camera off, no problem at all. Very soon you will find yourself in waiting room. Then you will put in the group, what happened? Is the session on? And that time I will reply to you in the group with very good emoticons and very good stickers. Okay, that is it. Shall I start asking? Okay, we will start asking. We will start with Tisha.
Yes, sir.
Tell me, Tisha, what does your name mean?
It's a Latin word which means joy.
It's a Latin word which means joy. Oh, that's a nice name. Nice name, Tisha. Okay. Latin word which means joy. Okay, good. Like physics is derived from a Greek word physis, which means nature. Okay. Where did Tisha? Tisha is okay. Tisha, tell me any three properties of electric lines of force.
Yes, they do not intersect nor meet each other. Then they enter normally to the conductor, and they are parallel and equispaced.
I think it's fine. Correct. Uh, Dhanushree,
Yes, sir.
can you tell me another 2 points which she has not said?
The line of force originated from a positive charge object and ends on a negative charged object, and
Hmm. And okay. Lost the connection, lost the answer. Abdullah Khan. I cannot hear you, Abdullah. Abdullah, can you hear me? Everyone else, can you hear me?
Yes, sir, we can hear you.
yes, sir.
Okay, I think Abdullah cannot hear me. It's time to put Abdullah in the waiting room then. 1 minute. Okay. Ruchit. I think Ruchit also cannot hear me. Time to put Ruchit in the waiting room. 1 minute. Oh, Ruchit is here. Manasri. Manasri, can you hear me?
Yes,
I cannot
sir.
hear. Manasri, tell me what is the difference between uniform electric field and non-uniform electric field?
In uniform electric field, magnitude and direction is same at all points, and in non-uniform electric field, magnitude and direction is not the same at all points.
Okay. Harsh.
Yes, sir.
Harsh, tell me. Any 4 properties of electric lines of force?
Mm, the lines of force originate from positively charged to negatively charged objects. First point, and second point is the lines of force neither intersect nor meet each other. Then, third point, the lines of force do not pass through conductors. Then, line of force uh, of an uniform electric field are parallel to each other.
Okay. Now the next topic, all of you, is our Coulombs law. Now Coulombs law is a very simple law. Just listen to me. What he said, if there are two charges Q1 and Q2. Okay, don't look at the law first, look at my explanation. I took two charges Q1 and Q2. Harsh, can you hear me, all of you?
Yes, sir.
Okay, am I more audible now? Is it better or that was better? Okay, now listen. Coulombs law, first thing you should know about Coulombs law is, Coulomb is the SI unit of charge. Do you remember that we studied in 10th also that the SI unit of charge is Coulomb. Now Coulomb was a scientist who studied charges so well that actually the unit of charge is named after him. It is named after Coulomb. And Coulomb's law, some of you might have already studied it in 10th, especially ICSE board had it as a part of their 10th curriculum as well. Please switch on your cam, all of you. Now, Coulomb gave a law. Now, what is the speciality of this law is, from your exam perspective, in the chapter electrostatics, Coulomb's law becomes the most important question, okay, because of obvious reasons. That is why define Coulomb's law, or what is the formula for Coulomb's law, or problems on Coulomb law are the most favorite questions for everyone in this chapter. So last class we studied what are the properties of charge. Remember, quantization of charge, additive nature of charge, conservation of charge. Today we did electric lines of force. Today we did uniform, electric, non-uniform, and today we are doing Coulombs. Out of all these topics, Coulomb's law is the most important topic. That is why for the next 10 to 15 minutes, please concentrate, because there are chances that in the next 10 to 15 minutes, whatever we study, only that will come in the exam. Okay. So what Coulomb did was, he took two charges and he separated them by a distance r. Means there are two charges which are placed at a distance r. What Coulomb noticed was the force between the two charges was directly proportional to the product of the charges, and the force between the two charges was inversely proportional to the square of the distance. So Coulomb noticed two things, that the force between the two charges is directly proportional to something, and force between the two charges is inversely proportional to something. force between the two charges is directly proportional to something, and force between the two charges is inversely proportional to something. Okay. Now, what is it directly proportional to? Force between the two charges is directly proportional to the product of their charges. And what is it inversely proportional to? It is inversely proportional to the square of the distance between them. Okay. I'll repeat. The force between the two charges is directly proportional to the product of their charges, and it is inversely proportional to the square of the distance. This is what Coulomb noticed experimentally. Now, after noticing this, he gave a law. I will repeat. Okay, you should understand the sequence of events. There are two charges separated by a distance r. Coulomb noticed that the force between them is directly proportional to one factor and inversely proportional to one factor. The force between them is directly proportional to the product of the charge, and the force between them is inversely proportional to square of the distance between them. Therefore, he made one law. Now the law is, look at this. The force of attraction or repulsion between 2 point charges. Why did he say attraction or repulsion? Can anyone tell me? Why didn't he say only attraction, or why didn't he say only repulsion? Why did he keep a question mark? He said the force of attraction or repulsion. Can anyone tell me why did he say that statement?
Because if one charge is positive and other is negative, then it will attract, and if both are same, it will repel.
Excellent answer, perfect answer. Because the charges can be positive, 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 negative. It can be anything. Then depending on the nature of the charges, it will be either attractive or repulsive. So can I say initially? I cannot say. If I tell you will two charges, listen to me, if I tell you will two charges attract or repel? Simple question. I am asking you, will two charges attract or repel? You will ask me back, it depends on the charge, correct? Whether it is positive or negative. Directly you cannot make a judgment, correct? So when I ask you, will two charges attract or repel? You will tell me it may attract or it may repel, depending on the nature. Because if both are like charges, we have studied in school that like charges are repelling each other. And we have also studied in school that unlike charges are attracting each other, correct? For example, look at this. Can I say if the two charges are like charges, that means if both are negative, there will be repulsion, okay? And if both are positive also, there will be repulsion. But if one is negative and another one is positive, there will be attraction. Do you know this already from school? That is why Coulomb said that the force of attraction or repulsion between 2 point charges at rest. Why at rest? Because we are studying electrostatics. What is electrostatics? Study of charges at rest, correct? What is electrostatics? Study of charges at rest. Therefore, everything in this chapter has to be analyzed when charges are at rest. Okay? He said that, listen to me. This law has to be written as it is in the exam also, because Coulomb said it. So you have to start with the force of attraction or repulsion between 2 point charges at rest. First is directly proportional to the product of the magnitude of the charges. That is the first one. And it is inversely proportional to the square of distance between them. And the force acts along the line joining the two charges. The last line I'll explain what does it mean. The force acts along the line joining the two charges. I'll tell you what does that mean. So now, tell me, what is the scenario? What did Coulomb take? He took two charges. Let it be Q1 and let it be Q2. And let them be separated by a distance of R. Tell me, what did Coulomb notice? Coulomb noticed that the force between the two charges, what is it directly proportional to? What did you observe? It is directly proportional to product of the magnitude of the charges. And what is it inversely proportional to? It is inversely proportional to the square of the distance between them. Now, depending on this, he gave a statement. Now tell me, what is the statement starting? The force of attraction or repulsion between 2 point charges at rest. All points are important, means all words are important, is directly proportional to the product of magnitude of the two charges, and it is inversely proportional to the square of the distance between them. And the force acts along the line joining the two charges. Means the force does not act like this. The force does not act like this. The force acts along the line joining the two charges. That means like displacement. You know, displacement is the shortest distance between 2 points. So force also acts between the line joining the two charges. For example, if one charge is here, other charge is here, tell me how will the force act? Force will act like this. This is scenario 1. Or force will act like this, scenario 2. Or force will act like this, 3. Or force will act like this. For which scenario will it act?
1.
Can I say
First
scenario
scenario.
1? Because it is directly the line joining the two charges. Therefore, look at the statement of Coulombs law and tell me if you can understand it, number 1. And second, if you can write it without seeing, or you want me to explain once more. Just look at the statement and tell me. This is the most important definition in this chapter, Coulombs law. So, should I repeat or you got it? If you got it, let me know, then we'll continue. Okay, so write down side heading Coulombs law. Just write down side heading Coulombs law. And
Explain the last sentence was once.
explain the last. Your voice is breaking. Explain the last. Statement. I'll explain it once more. I'll explain the whole thing again once more. But before that, write down the statement of Coulombs law. Okay, now below this, you have written the statement, and I want all of you to remember the statement as it is. In other words, you cannot write in your own words this statement. Okay, now you have written the statement. Now below the statement, write down side heading derivation. Side heading derivation. Draw the diagram where there are two charges Q1 and Q2, which are separated by a distance R. Okay, listen. Below this, that diagram write down. Consider 2-point charges Q1 and Q2. Write down. Consider 2-point charges Q1 and Q2. Consider 2-point charges Q1 and Q2. Consider 2-point charges Q1 and Q2 separated by a distance small letter r. Consider 2-point charges Q1 and Q2 separated by a distance small letter r. Full stop. From Coulombs law, from Coulombs law, from Coulombs law, write down equation 1 and equation 2. Did you understand what is the meaning of the equation? Look at the screen. From Coulombs law, I can get force is directly proportional to the product of the magnitude of charges. Equation 1 and equation 2. Force is directly proportional to 1 by r square or inversely proportional to r square. That is your equation 2. Right now. Okay. Below that, right now, combining 1 and 2. Combining 1 and 2. Tell me, if I combine 1 and 2, what will be the combined equation? If I combine 1 and 2, what will be the
Q1
combined?
Q2 is equal to 1 upon r.
Correct. If I combine 1 and 2, I will get force is directly proportional to Q1, Q2 by r square. Can I say my equation 3 is nothing but combination of 1 and 2? My equation 3 is nothing but combination of 1 and 2. If I remove proportionality sign, what do I get? Tell me. In physics, if I remove proportionality sign,
Constant.
Equal to constant, correct? I'll get equal to constant. Therefore, can I say F is equal to K Q1, Q2 by R square, correct? And F is equal to, listen, don't write. If I combine both the equations, I'll get F is directly proportional to Q1, Q2 by R square. Now, if I remove the proportionality sign, I will get equal to constant. Therefore, F is equal to K, Q1, Q2 upon R square. Correct? Now, listen. Experimentally, Coulomb found that the value for K is 1 by 4 pi epsilon naught. Now, what is epsilon naught? All that I'll explain. But experimentally, Coulomb found that K is equal to 1 by 4 pi epsilon naught. Therefore, tell me what will be the formula for force. F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. This is your Coulombs law. Now, what is epsilon naught? All that I'll explain. But first, finish copying this much. Epsilon naught. It is the pronunciation. Epsilon naught. Okay. Okay. Now, can anyone? Abdullah, yes, Abdullah is there. Abdullah, can you define what is Coulomb's law? Yes, start. Aditya, can you define what is Coulomb's law?
Yes, sir. Coulomb's law. The force of attraction or repulsion between two
Point charges.
point charges between 2 point charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the distance between them, and also the force acts along the line joining the charges.
It is, you missed out two important points. The first point that you missed out is, it is the charges are at rest. The first important point is the charges are
I
at
said
rest.
it, sir. Sir, I said it.
And the second point you missed is it is inversely proportional to the square of the distance.
Sir, I said it, sir.
You said square of distance?
Sir, I told rest also and square of distance also, sir. Inversely proportional.
Okay. We'll ask Ashna.
Yes, sir.
Can you define Coulomb's law?
The force of attraction and repulsion between 2-point charge at rest is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them, the point along the line joining the two charges.
Okay. So listen to this. I'll repeat once more the statement. So can I say, according to Coulomb's law, F is directly proportional to Q1 into Q2? Tell me, what else do we know from the first law of Coulomb? That the force is inversely proportional to the square of the distance, correct? We know these two things from Coulomb's law. And now if I combine equation 1 and 2, can I say F is directly proportional to Q1, Q2 upon R square? Is directly proportional to Q1, Q2 upon R square. Therefore, can I say, look at the screen, F is equal to K Q1 into Q2 upon R square, correct? Or F is equal to K is 1 by 4 pi epsilon naught Q1 into Q2 upon R square. Is it clear? Can I say, everyone switch on your camera. Can I say this is the Coulombs law? Now, what is epsilon naught? All that I will explain. But can you tell me what is the SI unit of electrostatic force? What is the SI unit of electrostatic force? Can anyone tell me that much? What will be the SI unit of electrostatic force? Can anyone tell me that much? What is the SI unit of electrostatic force? Can I say, since it is force, the SI unit of force will be Newton itself, because ultimately it is force. And you know that the SI unit of force will be Newton itself. Can I say that much is clear? SI unit of force will be Newton itself. Also, look at the screen. I told you SI unit of force is Newton. Now, if they ask you, what is the unit of epsilon naught? Can anyone derive and tell me the answer? What is the unit of epsilon naught? From the same formula, can you derive the unit of epsilon naught and tell me the answer? From the same formula, I'll give you 1 minute.
Sir, Coulomb per Newton meter.
No, but almost there. Not correct, but almost correct.
Coulomb square upon meter square Newton.
Okay, one answer correct. I'll anyway show it to you. But okay, this answer I can consider it as correct. Others, tell me. The formula is on your screen, and you just get the unit. Aditya, a small mistake, otherwise it is correct.
Coulomb per Newton meter square.
Coulomb per Newton meter square, almost correct. Okay, I will show it to you, everyone. Just let me know if you have understood this, okay? Now, can I say from the above formula, can I write epsilon naught is equal to 1 by 4 pi f into Q1 into Q2 upon R square. What did I do? I just put epsilon naught over here and I put F over here because I need the unit of epsilon naught. Now see here, 1 does not have a unit, 4 pi does not have a unit. Unit of force is Newton. Unit of charge 1 is Coulomb. Unit of charge 2 is also Coulomb. And unit of distance R is meter. Therefore, numerator will become Coulomb square because it is Coulomb into Coulomb divided by Newton, that is over here, and R is meter, but it is R square, therefore it is meter square. Therefore, the unit of epsilon naught is Coulomb square per Newton meter square. Now, did you get it, all of you? So now please make a note that the unit of epsilon naught is Coulomb square per Newton meter square. And also let me tell you one more thing. The value also is a constant, and the value is this is the value. So please remember this value as it is, means this will never change. And please remember this always, that epsilon naught is 8.85 into 10 power minus 12 Coulomb square per Newton meter square. This is the constant which you have to remember not only in this chapter, in all chapters you will have to remember this constant, that is epsilon naught is equal to 8.85 into 10 power minus 12 Coulomb square per Newton meter square. Make a note of this page. I'll give you 1 minute to complete it. Then I'll go to the next topic. Everyone, please make a note. Okay. Now, I can directly write 1 by 4 pi epsilon naught is 9 into 10 power 9. I'll tell you how. Because you know the value of 1. You know the value of 4. You know the value of pi. And now you even know the value of epsilon naught. Now, what is the value of epsilon naught? We just did it. It is 8.85 into 10 power minus 12. Pi is 22 by 7 into 4. If I do this calculation, I will get the value for 1 by 4 pi epsilon naught directly as 9 into 10 power 9. Therefore, in the problem, for example, when you're doing Coulombs law like this here, when you're doing Coulombs law, can I say I can directly substitute this 1 by 4 pi epsilon naught as 9 into 10 power 9 into Q1 into Q2 upon R square. Is this much clear? Therefore, you should remember two values. One value is of epsilon naught, which is this value. This is one value you should remember. And the other value you should remember is 1 by 4 pi epsilon naught, which is this, that is 9 into 10 power 9. Therefore, to give you a summary, what is the value for epsilon naught? The value for epsilon naught is 8.85 into 10 power minus 12. And the value for 1 by 4 pi epsilon naught is 9 into 10 power 9. Is this much clear? So these two values you should remember. Also, you should remember what is Coulombs law, what is the formula for force. Can you repeat what is the formula for force? 1 by 4 pi epsilon naught Q1 into Q2 upon R square. Understood. And what is the unit of this? The unit of this will be Newton. Clear? So now for today's class, go through first one is uniform electric field and non-uniform electric field. Second one, properties of electric lines of force. Third one, statement of Coulombs law. And the fourth one is this, all three. Formula, value of epsilon, value of 1 by 4 pi epsilon. Start. Okay, time up, time up, time up. Okay, so we will start, okay, again with the Viva. So we will start with Rutvik. Rutvik, I cannot hear you. Can you hear me, Rutvik? Knock, knock. Can you hear me? Okay, Rutvik, no problem, Rutvik. You keep doing that. I will keep asking other people. Then I'll come back to Rutvik to give the summary of the whole class. Okay, Rutvik, no problem. Okay. Darshan.
Yes, sir.
Darshan, now you have to tell me the answer. First time I did not ask you, correct?
Yes, sir.
Okay, Darshan, tell me, what is uniform electric field? You're on mute, you're on mute.
Whose direction and magnitude is same.
Okay. Ashna.
Yes,
Ashna?
so at my background some noise. That's it.
Okay, I understand. Renovation going on, na? Shreyash,
Yes, sir.
tell me what is the formula for electrostatic force? Very good, Shreyash. Can you repeat? Answer is correct. Answer is correct. When I have to repeat.
I didn't.
What? It is correct. Now, can you repeat? This is not good. Not good at all. Again, I'll give 1 minute for everyone. Revise quick. Okay, we will start with Rohit.
Yes, sir.
Rohit, tell me, what is the formula for electrostatic force?
F is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square.
Yes, good. Good answer. Okay. Suyash,
Yes, sir.
tell me what is the value for epsilon naught?
Epsilon 8.85 into 10 raised to minus 12 Newton centimeters C square, Coulomb square Newton meter square.
Akshat,
Yes, sir.
Akshat, tell me what is the value of 1 by 4 pi epsilon naught?
9 into 10 raised to 9.
Very good. I'll give you an MCQ. Solve it. I want you to give me the answer also, plus I want you to give me the logic also. Okay, so listen. Yes, this is the question. Start and give me the answer. I got answers only from 3 people. Let me check how many of you give me the right answer. Then I'll tell you the logic also. Rohit, correct. Shreya, Ashna, Darshan, both the Rohits correct. Aditya, Tisha. Others, Manasvi correct. Okay. Pashwa, no. I will tell you the answer. What is other people have given me either have given me wrong answer or have not given me the answer. In either ways, look at the answer. Now I know the formula for force, that is electrostatic force, is the 1 by 4 pi epsilon naught Q1 into Q2 upon R square. Correct? Now, by 4 pi epsilon naught is 9 into 10 raised to 9. And what they are saying is the two charges are of 1 coulomb each. That means Q1 is also 1, Q2 is also 1. Divided by, they are placed 1 meter apart. Therefore, R square is also 1 square. Therefore, I am left with 9 into 10 power 9 into 1, because 1 into 1 by 1 square is 1. Therefore, I am left with only 9 into 10 power 9 Newton. That answer will be B. Check 9 into 10 power 9 Newton. Therefore, for people who have given me the correct answer, very good. For people who have given me the wrong answer, this is the method. And for people who have given me the right answer, make sure that this is the same method you have also followed. There is no other logic to this question. This is the only logic. Therefore, if you have got the answer by any other way, that is wrong. Or if you feel that is right, unmute or message me and ask me, because this is the only way in which you can get the answer as B. Getting it, all of you? Therefore, I'll give you 1 minute. Make a note of this. It's a very simple MCQ. And that is why it is very, very good to know the value of 1 by 4 pi epsilon naught directly. 1 by 4 pi epsilon naught directly is 9 into 10 power 9. Okay. Now, okay, you want the previous slide? Okay, 1 minute. I'll leave this on only for 30 seconds. Then I'm going to the next question. Okay, now start with this and try to give me the answer. Okay, now let me see the answers that I have got. Now I've got the answers between A and B. So I'll tell you the logic. Now there is a parallel plate. One plate is positive plate and other plate is negative plate. Now an electron is placed between and the battery is switched on. Now tell me, electron will get attracted to which terminal, positive or negative? Can I say
Positive
electron is
terminal.
negative,
Positive.
therefore positive. Therefore, can I say when the battery is switched on, electron will get attracted to the positive plate? Therefore, answer will be A. Direct logic. Because unlike charges attract. Now I will change the question. Now this answer is A. This answer is A, that I hope everyone made a note. Now let me change the question. Instead of electron, I will use the word proton. Then tell me
B.
what will happen. If instead of electron, I use the word proton, then tell me what will happen. Then can I say the answer will be B? It will be attracted to the negative plate. Because proton is positive, it will get attracted to the negative plate. Now, instead of the word proton, if I use the word neutron, then tell me what will happen. It will keep moving, but it will not get attracted to any plate, therefore it will move parallel to the plates. Can I say neutron does not get attracted to either positive or negative? Proton gets attracted to negative, electron gets attracted to positive, neutron does not get attracted to anything. Clear? Therefore, but actual question was what? Actual question was electron question, correct? So in that particular case, what will be the answer? In that particular case, answer will be, it will be attracted to positive plate. Is it clear? Easy question? Okay. Start with this question. In this question, this is nothing but 8 into 10 power minus 3. And this is nothing but 2 into 10 power minus 3. Okay, they have made a print mistake. This is 8 into 10 power minus 3. And this is 2 into 10 power minus 3. Start. Okay. Now listen. Listen to me. I've got many wrong answers, so which makes me think that you don't understand the logic. But let me tell you the logic first. Tell me, what is the formula for electrostatic force? The formula for electrostatic force is 1 by 4 pi epsilon naught into Q1 into Q2 upon R square. Correct? Now, 1 by 4 pi epsilon naught Q1 Q2 upon R square. So tell me, what is the relation between force and distance? According to Coulombs law, force is inversely proportional to square of the distance. That we know from the statement itself. Force is inversely proportional to square of the distance. It means what? It means if I increase the distance, my force will decrease, and vice versa. Or if I decrease my distance, the force will increase. Now tell me, my force was 8 into 10 power minus 3. Now it became 2 into 10 power minus 3. The first question you should ask yourself is, did the force increase or did the force decrease? First question. Answer is decrease. From 8, it became 2. That means the force has decreased. Indirectly, it means the distance has increased because force is inversely proportional to square of the distance. That means I should know one thing for sure, that if force has decreased, the distance has definitely increased. That means 1/4 of the previous distance and half the previous distance will never be the answer because distance has increased. So it can never be 1/4 or half. It has to be more than 1. Therefore, automatically option A and option D are out. The confusion should be between option B and option C. Now, can I say the force from 8, it has become 2. Therefore, can I say the force has decreased 4 times, correct? The force has decreased 4 times. From 8, it has gone to 2. Can I say the force has decreased 4 times? Therefore, can I say the distance, that is R square, has increased 4 times? Can I say R square? Because force is inversely proportional to square of the distance. That means if force has decreased by a factor of 4, R square has increased by a factor of 4. If R square has increased by a factor of 4, R has increased by a factor of 2 because square root of 4 is 2. Therefore, R has become double. Therefore, the distance has become double the previous distance. Easy. Understood now? Okay. If you're not understanding, try it again. Then I'll explain once more. Before that, try to do it on your own and let me know if you've got the answer. Okay. This is the calculation on the screen. Okay, done. Should I explain again or you got it? Let me know. Should I explain again or you got it? Just let me know.
Sir, explain again.
Now, first thing you should know is the relation between force and distance. First thing you should know is the relation between force and distance. That means if the force increases, distance decreases, and vice versa. because Coulomb only said that the force is inversely proportional to square of the distance. In the question, they have said force was 8. From 8, it became 2. That means force decreased. That means distance has to increase. That means my distance has to increase. That means option A and option D are automatically out because in both the options, distance is decreasing. Now, force has decreased by a factor of 4. Force has decreased by a factor of 4 because 8 divided by 4 is 2. Force has decreased by a factor of 4. That means R square has increased by a factor of 4. That means R square has increased by a factor of 4, or R has increased by a factor of 2. What is 2? Double. Therefore, the distance is double. That's it. As simple as that. Got it, everyone?
Yes.
Okay, next. Start. Using Coulombs law, start this answer quick. Okay, I will do the starting for you so that you can get some clue. Okay, so listen to this. A charge plus Q. That means the first charge given is plus Q. Exerts a force of magnitude minus 0.2 Newton on another charge minus 2Q. That means Q2 is minus 2Q. And the force between them is minus 0.2 Newton. And they are separated by a distance of 25 centimeter. Tell me, 25 centimeter in meter, how much is it? How much is 25
0.25.
0.2.
25 into 10
25
power
into 10
minus
raised to
2.
minus 2.
Okay. Now I have to find the value of Q. So what I'll start with, I will start with Coulombs law. Tell me what is Coulombs law? F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 upon R square. Now, 1 by 4 pi epsilon naught and F. What is the value of F that is given? Check. Minus 0.2 equal to 1 by 4 pi epsilon naught is 9 into 10 power 9 into Q1 is plus Q into Q2 is minus 2Q upon R square is 25 into 10 power minus 2 the whole square. From this particular step, I need the value for Q. I will make it even simpler for you. Look at the screen. Minus 0.2 equal to 9 into 10 power 9. Minus 2Q into Q will be minus 2Q square divided by 25 into 25 into 10 power minus 4. Did you understand how? 25 into 10 power minus 2, the whole square is 25 into 25. 10 power minus 2 into 10 power minus 2. 10 power minus 2 into 10 power minus 2 is 10 power minus 4. So that this minus and this minus cancels. From this step, can you give me the value for Q? Start. Okay, I will continue with one more step. Trisha, I think your answer is correct. Very good. Trisha answer is correct. Now, look at this. I will erase the top part so that I can continue my answer over here. Just check. So if you notice the last step that I have done, and over here, I will start with the next steps here. 0.2 equal to 9 into 10 power 9 into 2Q square upon 25 into 25 into 10 power minus 4. Correct? Now please look at the screen. Now tell me 0.2, can I write it as 2 into 10 power minus 1? Can I write it like this? 0.2, can I write it as 2 into 10 power minus 1 equal to 9 into 10 power 9 into 2Q square divided by 625 . One minute, divided by 625.
So the screen is not visible.
1 minute. Can you see now?
Yes.
Divided by 625 into 10 raised to minus 4. Correct? Now, 25 into 25 is 625 into 10 power minus 4. Now, can I say, look at this. This 2 and this 2 will cancel. This 2 and this 2 will cancel. Therefore, now first find out the value for q square, and then you have to find out the value for q. Start. I will continue
Sir,
with the
can
next
we
step.
leave the answer in fraction only?
Actually, we can leave the answer in fraction. I'll tell you how we can leave the answer in fraction. Now tell me, I just want q square. So look at this. 10 power minus 1 into 625 into 10 raised to minus 4. What did I do? 10 power minus 1 as it is. And this whole term I took it over here is equal to 9 into 10 power 9 into q square. Tell me, did you understand this step? I just took the denominator on the left hand side. Or can I write it as 10 power minus 1, 10 power minus 4 is 10 power minus 5 into 625 divided by 9 into 10 power 9 is equal to q square. Understood this answer? Is equal to q square. Now, tell me, how do you continue? Anyone has any idea? How do you continue? So can I say q square is equal to 625 into 10 power minus 5 upon 9 into 10 power 9. Now can I say if I take 10 power 9 to the numerator, it becomes 10 power minus 9. Therefore, can I say 10 power 9 becomes 10 power minus 9. Now what is 10 power minus 9 minus 5? It becomes 10
Minus
power
14.
It becomes 10 power minus 14, correct? Also, q square is 625 by 9 into 10 power minus 14. Therefore, I will take square root on both sides. Therefore, it will become 625 by 9 into 10 power minus 14. So look at this. Q equal to, tell me what is square root of 625? Do you have a direct answer for square root of 625?
25.
Do you have a direct answer for square root of 9?
3.
3. Do you have a direct answer for square root of 10 power minus 14?
Minus 7.
10 power minus 7.
You can leave the answer like this. Easy, got the answer. Ultimately, it is only mathematics. Physics is just the formula, and I did it with many steps. You can simplify it with less number of steps also. I showed the longest possible method. You can skip some steps or you can do multiple calculations in a single step also. Answer is this. Okay. They have in the module, they have done it like this. In fact, they have actually taken square root of this, which is very difficult. This becomes very easy because here we are getting every term as a perfect square. So you can take square root easily. Is it clear, all of you? Okay. Now, remember when last topic, okay? Write down spheres in contact. Topic's name, last topic for today, spheres in contact. Now remember, if there are two metallic spheres, okay, look at the screen. If there are two metallic spheres, doesn't matter they are radius or doesn't matter their size. If this is sphere A and this is sphere B, remember, does not matter what is the size of the sphere. If this sphere is carrying a charge of 40 coulomb, and if this sphere is carrying a charge of 10 coulomb, okay, and they are brought together, means they are touched, and then they are separated. They are brought together, and then they are separated. What will be the charge on each sphere? That is the question. If they are brought together and they are separated, what will be the charge on each sphere?
25,
So can I say when they are brought together, the total charge will be 50 coulomb? Tell me how, because the both charges are shared. And when they are separated, each sphere will take equal amount of charge. Each sphere will take equal amount of charge. That means out of 50 coulomb, sphere A will take 25 coulomb and sphere B also will take 25 coulomb. That means they will always take the charge in the ratio 1:1. Does not matter what is the radius. Means equal charge they will take. Understood this illustration? Make a note, then we'll do one or two examples of this. Start. Make a note of this. When two spheres are brought in contact and then separated, what happens? This is what happens. Make a note. Now we will do the next one. Now we'll do the next one. See this. Okay, now listen. Sphere A has a charge of minus 20 coulomb and sphere B has a charge of plus 10 coulomb. Tell me what will be the charge on each sphere if they are brought together and then separated. Tell me the answer. Correct, Tisha. Very good. Others, give me the answer. Okay, the answer will be, listen to this. When the two spheres are brought together, minus 20 and plus 10, when they are brought together, the total charge will be minus 20 plus 10, which will be minus 10, correct? The combined charge. And once they are separated, each sphere will get half of it. So what is half of minus 10? Each sphere will get minus 5 coulomb. Again, if you notice, both will get charge in the ratio 1:1. Doesn't matter what their radius is, they will get the charge in the ratio 1:1, equal. But for that, they should first come in contact and then be separated. With that, I will do one more problem and then I'll take you to the MCQ. Now look at this. First sphere, second sphere, plus 30 minus 40. Start. Okay, now, can I say plus 30 and minus 40? If I combine together, the charge will be minus 10 combined. And that minus 10, once they are split, each one will get again minus 5 and minus 5, again in the ratio 1:1. Understood? With that, we will do one last MCQ for today and then we will stop. And the MCQ that I'm going to show you is, I want you guys to give me the answer for it. The MCQ is, yes, start. Okay. Answer is, a metallic sphere A is charged and this is in contact with one more sphere and the charge on the two sphere. Now you know that once they are brought in contact and separated, the charge will be equal. Doesn't matter what the radius is. Therefore, can I say both will get the charge in the ratio 1:1 itself always? Doesn't matter whether it's big or small. When they are brought together in contact and separated, the ratio of the charges will always be in the ratio 1:1. Is this MCQ clear? Okay. All of you, answer will be D, 1:1. Okay. Okay. With that, we come to the end of today's class. The homework is to complete today's notes, whatever I have given you, and submit it as a PDF. Also, if you have any doubts in today's class, you can stay back. If you have understood whatever is done, you can log off. Thank you. I will see you next week. If you have any doubt, please stay back.
Sir,
Yes.
sir, can you explain the other 2 points of electric lines of force? The last 2 points.
Last one. So I'll explain, let others log out, then we'll do it one-on-one. Yes, if you have no doubts, you can leave. Thank you. Yeah, the last 2 points are, they take off and they land normally, means they take off and land perpendicularly, like a helicopter. You know, helicopter takes off perpendicularly and lands also perpendicularly. That is the last point. And the last point before that is, they do not enter inside a conductor, because if they enter inside a conductor, they will intersect. Therefore, electric lines of force do not enter inside a conductor. These are the 2 points which you had missed.
Okay, sir. Sir, can you show them? I will take a screen.
Yeah, this one.
Thank you, sir.
Okay. Akshat, any doubt? Shreya, any doubt? Sujal, any doubt? Let me know. Akshat, any doubt? Shreya, any doubt? Sujal, any doubt? Let me know.
So I in comment box I gave you the doubt, sir. Sir, you gave one question in the homework. I had doubt in that.
What is the importance of energy gap in a solid? The importance of energy gap is depending on the energy gap, we come to know whether the solid is a conductor, semiconductor, or insulator. That is the importance.
Okay,
Depending
sir,
on the
thank you.
energy gap, we come to know whether it is a. Understood?
Yes, sir. Thank you.